Welcome back to a lecture series on hydrogeology. So in this lecture now we are going to discuss about the water purification. Water purification is the process of the wastewater, bringing the wastewater into the normal water. Of course, that is people have started water recycling. So that is the era now. We have slowly moved from water recycling process. We have to effectively use, because the water system, the groundwater system or the surface water system has gone down slowly over the period of time. Since last 100 years, if we just check every 10 years, the quantity of water on the surface and off the surface is reduced. Now we have to effectively reuse the water. The developed countries have already started the process of recycling. And here is the picture shows that here is the picture shows that the various process of water purification. The raw water is taken and then it is processed by the various methods we will discuss one by one: coagulation, flocculation, sedimentation, filtration, and treated water, and then water is distributed. So the process we will see how the aeration is done, how the sediment settlement is done, how the disinfection is removed, and how it is being supplied. So the water purification, the process started of removing coarse particle first, the process of coagulation by means of aeration, flocculation by means of adding chemicals, and removal of fluoride, defluorination, and removal of disinfected materials in the water, and removal of smell and smack in the water by the process deodoration. So these are the various steps or process involved in the water purification system. And when the water purification system comes, that the raw water, it means, infected water is taken, not exactly the raw water. The water, because recycle process purification starts from the wastewater. Not we always use the raw water. Sometimes raw water, contaminated raw water has also been used. Do you allow the water by means of aeration process like coagulation and fluctuation by adding the chemicals into it, and then allow the water to settle down for some time, and then you treat the water, make it filter, and then bring the water disinfection basin and treatment waste storage, and then send the consumption. Flocculation is a process by which chemical coagulant added to the water act to facilitate bonding between the particles and creating large gels. Of course, we will see the details now. The first process, look at this video. You just allow the water for some more time. The muds are deposited at the bottom. Because if you just, this is the sedimentation, muds are settled down. And now you take the water and then in the other beaker, and you look at the water again, a little bit of silt, decantate is there. Again you allow the water or make it a filter, use a tea strainer or some filter. So you will get, that still more some fine sediments here. And you allow the water for some more time. Like this you have to do it continuously, so that what will happen, the water will become good. At the last stage all the sediments will be removed, and then we will get a good water. So this is how it's being done. You see, you give striations and then check the water color and then allow the water. So this is the movie. What does it mean? That the very coarse particles in the water can be removed by simple sedimentation process. In still water, the above impurities tend to settle down under gravity forces. You allow the water for some more time. The principle is called sedimentation or settling. Hence, water is allowed to stagnate for some time until the coarse particles will settle. This process is called settling process. The basin in which the flow of water is retarded is called settling tank or a sedimentation tank. This is called settling tank, and sediment particles in suspended water allow for some time. It gets deposited. This is called settling tank or sedimentation tank. And if the sedimentation tank comes, water containing insoluble impurities, and then you allow the water for some time, clear water is on the top due to the gravity, all your insoluble impurities are settled down. The lower layer consists of coarse grain and gravels. This layer is consists because in the last video we have seen. The filter does not require chemicals, and the design is simple. It's very simple, but for a huge quantity of water, even we have visited many of the education institutions how they are doing the purification process. It's a big tank. I have seen in some of the institute like 8 lakh liter of wastewater in a day is being captured back, and then 6 lakh is taken back by the said process like coagulation, fluctuation, sedimentation, and all this process. They started reusing 6 lakhs in only the loss is 2 lakh every day for a big institute. And similarly, this will be the case in future. We will start to reuse the water. You know that this recycled water, mainly if you are not feeling, I mean, good to use the water, we can use it for the agriculture practice or the that sanitary purposes. We can use the water on different uses like sedimentation process and coagulation. And what is the coagulation addition? You see the water, the rapid mixing first is done, and then slow mixing is done, and then it is taken to a clarifier, and the sludges are taken out. The sludges or the fine dust, it is taken out, and treated water is taken, filter after the filter for the next process. It is nothing but it is fire dispersed particles are removed from water by coagulation. That is by treating the water within a special reagent which enlarge particles to promote their precipitation. The coagulation process is used to clarify the decolor of water. Water sometimes may be polluted by human silica, human clay, and silica. They are removed, that with all this process, they are removed by coagulation with the salt of weak bases and strong acids. So this is the process behind the coagulation fluctuation process. And the agent is added, coagulant, yeah, is added in the water. Impurities are that allowing the water. Coagulant forms precipitate and trapping the what is that the impurities here, and then it takes the impurities and then gets settled down. Precipitate and trapped impurities settle at the bottom. See, this is coagulants for wastewater treatment. And coagulant addition, this is another figure, impurities before, impurities during, impurities after. What does it mean? That coagulant absorb onto impurities, it is takes the impurities, and flocks are formed and settled at the bottom. This is called flocculant. This is contaminated water, disinfecting, and then disinfected water. This becomes aluminum sulfate, that is alum Al2SO4 and ferric chloride are the most commonly used as coagulants. So keep it in your mind, Al2SO4 and ferric chloride. Normally this is being used, aluminum sulfate. Apart from these copperous and ferrous sulfate, FeSO4 H2O, 7H2O is also used as coagulant in conjunction with lime. You have to use lime also, lime acid. Besides aluminum and iron salts, sodium aluminate Na2Al2O2 is also sometimes used as coagulant. This depends upon the water type and the quality poor water, and we actually use this coagulant addition. Now, what is flocculant? Flocculant is the process you see, rapid mixing, slow mixing. This is what in the last figure, where this will be there, huge amount of bubbles will come first, and then slow in the second process automatically. You see before negative charge, and then this is neutral charge, and then settle agglomerates. So this is the process before, during, and after. The coagulation process can be intensified by adding special agents known as flocculants. The following substances are used as flocculant starch: sodium polyalginate, polyacrylamide, activated silica, and a copolymer of vinylazide. So these are all the flocculant agent has been used here for removing the impurities in the water. This is the process. I know that in stage 1, in the first chamber, we have a fan-like structure here. This will move, this will activate after adding the reagent. So this will rotate, you will get, bubbles on the top of it. It interacts with the air, impurities, and get to sound. In stage 2, in the fluctuation chamber, once if you added, it is with less, and then it takes all the impurities. And you know that the process will be very slow, because it is fast here, it is medium here, and it is very slow. And finally, you will get all your, the sediments at the bottom. The process behind the water purification in the next stage is fluorination and defluorination. And all our water needs to be, with free of fluorine. Otherwise, this lead to a big issue on fluorosis. Initially, the teeth will become like this, and slowly, that all the teeth is corroded, and then it becomes so weak. Finally, you lose your all teeth. It will not affect only this; it will affect up to the teeth, root of the teeth. When in small quantities, fluorides are a vital necessity for man and animals. Fluorine is a component part of bone and teeth. Tooth tissues contain about 0.02% of fluorine, its major part being into tooth enamel, whose composition is close to the formula of Ca5F. Normally, apatite is the source rock for the enrichment of fluoride, and even some of the feldspars, which contains small amount of fluoride. But excess of fluorine in water and air is poisonous, since all fluorine compounds are poisons for the human is concerned. And you see the dental fluorosis slowly attacks, and then it started killing the teeth. You see, you look at it. This is not leave even the children, small children. So at the age of 5 or 6, you look at that, all bones for these children. It is, look at that, all bones of the children. What will happen if they grow and they come to a normal? This is very bad. This is called skeletal fluorosis. This is called dental fluorosis. According to sanitary requirement, the fluorine content of water should not exceed 1.5 milligram per liter and be less than 0.7 milligram. It should not be less also, it should not be high also. Fluorine poisoning destroys enamels of the teeth and makes the bone brittle. That is called skeletal fluorosis. This affects the joints of joints. It affects kidney. It affects liver. It affects heart, adrenal gland, taste, thyroid, taste and thyroid gland. Almost major organs in human body is affected by because of this higher fluorine content. So with this lecture, the fluorine contaminated water adsorption technique is being used to remove. What is the adsorption? Fluoride contaminated water is being sent to bioadsorbent agent, oxide and hydroxide agent, and carbonaceous materials, industrial byproducts, and geomaterials. If you use the water through this, automatically the concentration of fluoride in the water will decrease. So you will get a fluoride free water after the process. Water containing increased doses of fluorine should be defluorinated. This is the process. And on the contrary, fluorine poor water should be fluorinated. Your aquifer is here, and then take the water into a system and then keep your metal oxyhydrates here. What will happen? This will flow and into this media, and it will interact the water fluoride content with this media, and then for defluorination, water is treated with aluminum sulfate Al2SO3. Fluorine forms a strongly soluble AlF2, which is precipitated together with aluminum hydroxide, sodium carbonate, also used as defluorination agent. Keep it in your mind that aluminum sulfate and fluorine forms a strongly soluble AlF2. S becomes, that interaction, it joins and which is precipitated together with the aluminum hydroxide. So, right, sodium carbonate also used. There are two things, aluminum sulfate and sodium carbonate is used. Disinfection of water, boiling of water or chlorinization of water is carried out for the sole object of killing infective organism. When you use this process, this is called a disinfection of water. Water can be disinfected by keeping at boiling point 15 to 20 minutes. You will have to boil all the waters. All the disease carrying bacteria are killed and water becomes safe for use. Mostly the educated people will do that when they take water. Normally they take with the hot water. The chlorine gas and chlorine compounds such as chlorinated lime, chloramines, chlorine dioxide, hypochlorite as well as salt of heavy metals are effective against microorganisms. Water in swimming pools can be disinfected by iodine. The disinfection of water is also carried out by ozone. Let's be very careful on using this. Different methods of disinfection. You have a boiling method, you have a chemical treatment, and you have ultraviolet C disinfection procedure. Removal of smack and odor. This is called deodoration. Smell, that is odor, can be due to phenols, hydrogen sulfide, chlorines, soluble salt. And this will makes you unpleasant. Be careful. And the smack can also be due to synthetic surface active substance like pesticide used for agriculture to control insects. They give the water unpleasant color, unpleasant smell, and smacks even when in a negligible quantity. Even though if it is very small, we don't feel it. We don't feel happy to take the water. Yes, it is true. Every human being will never take the pure and unpure water. The method most commonly used to remove odor is passing water through activated coal which absorb contaminants. So you will have to pass the water through activated coal. The deodorizing effect of chlorine can be strengthened by adding permanganate, potassium magnesium oxide, permanganate. If you add, automatically the smell will be reduced. With this, the water purification discussion is come to an end. Thank you very much.